Let's see if YouTube succeeds. I am live on YouTube. I am live on Twitch, and I guess I will go ahead and be live. Yeah, okay. I am live on Discord as well. So, wow, there's a lot of liveness everywhere. Hopefully YouTube is hearing the voice as well. I think it is. I think it should be. I just don't see much of a meter there, which is odd. So we'll go for it. All right. So, hey, drop in at this time, whatever it is, wherever you are, whatever time of day, day, night, whatever. So we're going to talk today about inheritance a little bit. Okay, so this is it's not a requirement of the last project. If you guys are following along, getting intro to game programming projects done, you don't really need to be using inheritance, but it might be something that comes in handy for you to do getting your projects working. So let's see. Nope, that's not the one. That's not the one either. Where is my other screen? Here's my other screen. All right, there we go. Present. All right, let's talk about inheritance. So if anyone is on YouTube, give me a shout to say yes, that you can hear me on YouTube. I'm just going to ask over there. I feel like I don't know what I'm doing. It's just like way too many things going on at once. Okay. So let me pull up Discord again. All right. So inheritance. What is inheritance about? Well, it's about not reinventing things. It's about decoupling things. It's about reducing redundancy. It's about creating design where you can add functionality to existing objects, where you can improve things, where you can kind of build on things without reinventing the wheel. So you shouldn't be reinventing. You shouldn't be cutting and copying, pasting. You should be using inheritance, right? This is one of the big object-oriented features that we like to be able to use, that we can kind of leverage our work and build new things from our work and streamline the process of software development. So inheritance, the basic idea behind inheritance is creating things in such a way as you start with generalization and you end with specificity. So you start by saying, okay, what is something in general? What is an animal versus what is a dog? What is an automobile versus what is a Ford Fiesta? This sort of thing, right? You start with something that's a general concept that has certain things that it does. And then as things get more and more specific, dogs, let's see, mammals are all warm-blooded and have fur and live offspring, as opposed to dogs, which have canine teeth and bark, right? Dogs are also mammals. They have live births. They have fur, but they also specifically bark and have canine teeth. I guess there's probably other things that have canine teeth. But anyway, so we're going to use this automobile, car, bus, Ford, et cetera, kind of demonstration. Hopefully this sort of makes sense. All right. So inheritance, okay. The basic idea we'll talk about in terms of programming is that you are defining one class being one of our fundamental building blocks here. We define these structures as classes. We define one class in terms of another, so we can make more sophisticated classes based on other classes that we've already built. We normally start off with a base class. You create the thing that is the initial existing class that has certain kind of general data and behavior, and then you can derive new classes from that base class that extend the base class in some way, right? It inherits all of the common traits and builds on it from there. You can add new things or modify existing things. So maybe, the car, instead of having some about the base to make them more refined and so on. All right. Now in C#, this is some other languages you can do multiple inheritance, but in C#, each class can only ever have one other base class. So it starts off as one class and it inherits the properties of that base, and then it has a new class. So each one can only have one base class. However, you can chain base classes together infinitely, right? So you can have parents and grandparents and great-grandparents and so on that are, inherited from in order to get down to the children, so to speak, right? But you can only have one base class per class, right? Now, normally this is what we do even with monobehavior classes, right? This is what we do. We are inheriting from our monobehavior. That is the base class that most, not all, but most of our Unity objects inherit from. Sometimes we're also inheriting from things like scriptable objects and so on, but normally we're using the monobehavior class as our base and building on from there. All right, so we've seen that before. We have used inheritance already, right? Just in using our start and update and the kind of things we have built our new class based on the monobehavior class. All right. Now, we've probably seen things. You've seen public and private. Those are not new concepts in here, but it's interesting in that, okay, public and private basically say how do other classes deal with the information held within our class, but we have to think about what happens when we have classes that are derived from one another. Right? A derived class can only access functions and variables from the base class for which it has cases, differences between classes. So they're sort of distinct classes from that perspective. However, sometimes you might want to have things that a new class inherits from a base class that are still sort of private to that new class and private to that base class, right? So what we can do for those is we call them protected. So protected marks a variable or function as visible to the class and any derived classes, but it is private for all other classes that do not inherit or derive from the other from this particular base, right? So you'll see protected start to show up. All right, so why do we have these things? Why do we want to use inheritance? Well, inheritance is appealing in that we can use it can be used to define a common structure on which to build similar but not entirely identical classes, right? So you have some concept that you want to share between a bunch of different things, and you want to define, like in the case where I was saying a mammal, where a mammal is, has certain things that it does, and then you want to build other things from there, or maybe there's like an enemy that has certain ways of moving, or certain, things that the enemy always has, certain structures, certain components. And then from there, you might want to build specific ones. Their enemies might be orcs and goblins and trolls and so on and so on and so on. But they all have common things. Like those orcs and goblins and trolls, they all are bipedal humanoid characters. So they might have certain things that they do, So each derived class starts off with the base class's general functionality and structure, and they add methods and properties on top of that base class. Okay. But now it's interesting. What if you want to change the base class's existing functionality? Some piece of it you want to make different. So you want to inherit a whole bunch of things except for this particular thing, right? So you want to have its movement system inherited, but that basic damage behavior you want to override. There, I let the cat out of the bag. To override with some other amount of functionality. So you can modify behaviors of the base class when you're creating your new classes. So in order to modify existing values, there are some other keywords for us to remember. We have this virtual, which will mark a function in a base class as being able to be modified. An override marks a function in the derived class as taking the place of the base, right? So the virtual appears in the base class, meaning that it could be modified in the derived classes, and the override tells us explicitly, yes, we are using this function to override a class in the base. Now, these are explicit ways to do it. And the nice thing about it is if you're doing it explicitly, then the compiler and the tools will be able to tell you, okay, for example, if you're trying to override something and you put in a name and you try to override a function that doesn't exist, it'll warn you, right? So okay, I can't override functions that don't exist. Now, you could, and you may have seen, like in the case of mono behaviors and so on, we didn't have to mark everything as being overriding. That's because there are ways to not do this, but we like to have them explicit so that potentially the tools can kind of help us to do the right things. Now, you can also use the base keyword to access a virtual function's original behavior, right? So if there has like a start routine or a shoot bullets routine, you want to preserve the original, but add on to it, you can use this base keyword like this. Okay, it's commonly used when you first do the base behavior or secondarily do the base behavior. Then you add additional functionality before or afterwards. So you might say base.doStuff, right? So here's an example of modifying the base class. All right, so in this case here, hopefully you see, we have an enemy which inherits from this mono behavior. And the enemy has a basic thing it can do. It can move. And we know that other enemies that we create may have their own move routines, but we know they're also going to have this type. So they'll always have a type, and they will always have a move, but this is the basic one that we'll use if they don't provide one of their own, right? So then we could derive things from here. So for example, we could derive a new class, which is called a diver. We can derive a diver from an enemy, meaning a diver is an enemy, but it might have additional new functionality, like it might have its own awake function. And in that awake function, we may set these and access and set these variables that are part of the class to our own values. So here we are. We're not really overriding here. We're just assigning. We're doing an assignment to a base variable, a base property here. We're saying type equals diver. And then it is also providing its own move function, right? So here it is actually overriding the virtual move function with its own swimming overwrite the type with boss, and then we override the move function with its own move function. But in this case, we call the base classes, the base enemy classes move function, and then we add functionality to that move function. And we also add a new function down here called shoot. So we can have this enemy shoot at us, for example. Okay. So this is the basic use of kind of inheritance. So we create a base class called enemy, which inherits from mono behavior. And then we have two new classes, the diver enemy and the boss enemy, right? They share this common ancestor and they have some new functionality to them. Okay. Excuse me. I had a little after lunch there. Okay. Now, here's a trick using inheritance with ToString, for example. Now, ToString is a function call for objects in C# to display them as a string. It is marked as virtual, so any object can override this function to set custom behavior for displaying itself as a string. So, for example, if you wanted to create a card and it had a suit and a number, which are both strings, you could override that so that when you said, okay, ToString for this, it will put these two things together, right? So this is an example using ToString to define things and inherit things, all right? Now, we're going to stop there before we get into some more object-oriented techniques. Because I want to demonstrate, it's going to be kind of a short introduction, then I might pause for a little bit. I want to show a little bit of an example here of how I use, but let's play. See, we have this little character in the game who runs around and he has this ability to flip coins or throw coins at enemies. And he also can convince squirrels to follow him. And squirrels get put in the squirrel house there. And you'll see the number of squirrels I've caught and the number of enemies that I've dispatched. 2 and 2. And let's see, let's rescue this squirrel over here real quick. Oh, squirrel, notice me. Yep. drag him up, bring him up in here, and drop him off. Come on, there you go. Okay, 3 squirrels caught, 2 enemies dispatched. Now, this is my normal weapon, or my normal attack is this shoot one, flip one coin. Ah, congrats. You can multi-flip now. Okay, so now I have this ability to, whoop, and it went away. I shot too many times. It overrode itself again. I gained some new ability. Now, there's a gold chest over here, which I'm going to grab. Congrats again. And you'll notice this one is a 8-way weapon attack. Okay. I have a couple of different weapon attacks there. So let's look real quick. In my scripts, we will see, and let's see, there we go, weapon, for example. And I will call up track of certain things. The last time it was fired, the thing that it fires, its coin prefab, the number of shots that have been fired, the bullet speed, and so on. And then what does it do? Well, it keeps track of the start. It has a cooldown here, right? So it says, okay, if the number of shots is greater than a certain amount, you know, so you can't shoot more than once every half second. And then it has an actual shoot routine. Okay, it basically says, okay, what direction? Now the direction is passed to it, right? This shoot routine has the direction passed in. And it says, okay, if I have, there are some ways to speed up, kind of turbocharge the bullets as well. But this is the basic idea. You know, if you have, if you've called this less than a quarter of a second, it has a faster bullet, but normally it just shoots it at its bullet speed. And then it schedules that bullet to be destroyed in 3 seconds. This is where it decides, okay, how do you fire the weapon? All right. So it does a little bit of work to figure out, all right, here's where I'm going to aim, right? It will basically aim the weapon. So look at our mouse position and so on. Figure out what direction it should shoot in. And then here's where fancy part in here. This just makes sure if we are clicking on the dialog box, we don't accidentally fire. So it says, okay, as long as we're not clicking on anything in the UI system, right? We fire, we say, okay, we can shoot, right? We shoot in a certain direction. Now, here's an interesting part. So what I did here is there is a system by which if you shoot too often, if shots is greater than 5, it will demote your weapon. All right. So it is overriding your weapon with a demoted weapon. So you have to sort of be careful there, right? Because we will demote your weapon, right? Yeah, we are basically adding, what we do is we add a weapon component and we destroy the existing weapon component, right? So that seems odd, right? In that we're adding a weapon and we have this is piece. This is the kind of the unusual part, right? This is weapon 2. This is weapon 3. What does that mean? Well, this class here is weapon, but what it looks like it's asking is saying, okay, if this, which is this class, is weapon 2, so if this is another class, this is weapon 3, yet another class. Now, the reason this works is because weapon 2 and weapon 3 are actually also weapons because they derive from this class. Kind of crazy. All right. So weapon 2 class inherits from the weapon class. And the only thing that happens in here, it doesn't set up its cooldown, it's all those different functions and the direction to shoot in and so on. all it does is say, okay, I'm going to override the existing shoot function with this new shoot function, right? And the first thing it does is says, okay, but then additionally, what I do is I fire that burst. I fire that 4-directional burst of coins. And I won't go into all the details here, but I'm basically, instantiating a coin at that same position with no rotation, but then I throw it according to, I give it this velocity in a direction that I iterate over here. I say, okay, at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and so on. So we get our 4 directionals, right? 0, 90, 180, 270. And each of those bullets, each of those coins gets destroyed after, right? So this happens on top of the other call here, right? But this is the cool thing. I can use this. This is weapon 2, and it will say, okay, this is the thing that's happening. The update routine, whether it's a weapon or weapon 2 or weapon 3, they're all sharing this same update routine. But within there, I can check and see what flavor, as long as it's something that's, if I want to demote it, see, okay, if you're a better weapon than the one we are here, we can create the base weapon and demote your other. Now remember, it only has one weapon at any particular time. Either a weapon 2, or a weapon 3. It doesn't have multiple ones. It may feel that way a little bit, but that's not what's happening. It's you have a weapon 2, or a weapon 3, which is why it's going to create, in this case, because it's getting rid of a fancy weapon and replacing it using this game object add component to add the plain vanilla weapon back in. All right. And then if we looked at weapon 3, weapon 3 is similar, and it derives from weapon 2. This is kind of a fancy, little bit of a crazy way to do it. In which case, what it does is it says, okay, this is doing everything weapon 3 does, or weapon 2 does, but we're overriding shoot one more time. So this is going to call the existing shoot for weapon 2, right? Which was the, oh, some reason it's not open. This version. And then it's going to call this version. And then ultimately it drops through and calls this version, which adds an additional 4 coins, this time at 45-degree angles. So we're shifting our rotation by 45 degrees and then having it at 45, 90 plus 45, 180 plus 45, 270 plus 45, right? So that's how we get the rest of that starburst. Right? So that's how the inheritance is working. We've actually inherited twice. Weapon 3 inherited from weapon 2, weapon 2 inherited from weapon, and then weapon inherited from mono behavior as well. All right. So that's where all this is happening. Now, so you might be asking yourself, well, how is this weapon changing? And this is actually happening in the hero. The hero does this thing where if the hero collides with a power-up, there's a trigger. So inside the hero's routine, it says, okay, if I collide with a power-up here, if collision compare tag power-up, right? First thing I do is I say, okay, in a little bit, get rid of the thing I collided with, but I'm going to do this. I'm going to destroy whatever weapon I currently have. A weapon 3, if I hit a weapon power-up 2, or just adding a weapon 2, right? So this is where I'm saying, okay, my weapon, and I'm adding this new weapon here. When I add component, it's adding it to this object here. So it's adding to me, adding to the game object that I'm on. So it's going to replace the current weapon with a weapon 3 or a weapon 2. All right. So let's let that sink in a bit. I'm going to go ahead and let that sink in a bit. And we'll do a part 2 in a little bit. Okay. So we've had a derived weapon system and using this on trigger to install whatever weapon I want, 1, 2, or 3. And then also in the weapon system, it can demote itself if you shoot too quickly. Kind of neat.